Hi guys. Hope you guys are doing well. Okay. We're discussing chapter 3, the hypothesis testing for one population, two population, and independent samples. STTN124. Okay. So, mm, start one. Yeah, but I won't start with the question papers. So what I'm going to do, I have 2023 question paper. I have 2023 question paper here, and also 2024 question paper. But unfortunately for 2023, 2024, I've managed to get only the question paper plus the memo. So it's question paper plus memo, you see, something like this. But it's very important to understand how they got those answers. And then I also have 2019. So for 2019, it's only question paper for 2019. Okay. So what I'm going to do after explaining chapter 3, I will start with 2024 as this question paper semester test was just 3, 2024. And after 2024, I'll also do 2023, chapter 3, 2024, chapter 3, 2023 question paper. Okay, where's 3.1? 3.1. This is hypothesis testing for one population. Let's see. Choose this one. Okay. 2024. This is hypothesis testing for one population. Interesting one. This is interesting. Just put this here. Put the top. Yeah. So now with this one here, the hypothesis testing for one population, which is under 3.1. Interesting. So let's check. So with the hypothesis testing, remember we're going to use the steps of the hypothesis testing to make a decision. To make a decision in a systematic manner with regards to the population mean. With that population mean, it's either the sample one or the large samples. Okay, let's just go straight to the, okay, we can just check this one. It's the definition, the statistical inference, which we are talking about. It refers to the method that it is used to do what? To make conclusions about the population. And that population is from the sample data. It is this one. And a statistical hypothesis is a statement or is a claim regarding a population parameter. And that population parameter, remember, it can either be population mean or a population proportion under this one. Yeah, I'm just gonna go straight to the steps. So now, under hypothesis testing for this one, we have hypothesis testing for one population, and we have hypothesis testing for two population. So the most important thing here is for you guys to know, how do you see, like when you're given a scenario, how do you see that on this question, or when you look at the scenario, how do you see that the question is based on the hypothesis testing for one population, or the question is based on the hypothesis testing for two population? And how do you see that? I'm going to explain now how do you see that when I explain the question, when I do 2024 question paper, 2023, and also 2019. Okay, let's start with the hypothesis testing. So for the hypothesis testing for one population, two population, and independent random samples, we're going to use these steps. The steps. Step 1, step 2, step 3, step 4, and also step number 5. So step 1, it's when you formulate the hypothesis. This is when you formulate the null hypothesis, SHO, and the alternative hypothesis, SHA. It's when you formulate. Then step number 2, it's when you specify the level of significance and you write down the correct formula of the test statistic that you're going to use. Then step number 3, it's when you calculate the test statistic for step number 3. Then step number 4 is when you compare the p-value. You will be given the p-value. But for those who are doing STTN124, you are not given the p-value. You will have to calculate the p-value by using the standardized normal distribution table. either table 1A or table 1B, the positive one and also the negative one. And then you compare the p-value with the significance level that you will be given. Remember, you will always be given the significance level. And for 124, you will also be always given the p-value, the probability. Now, after on step number 2, when you write down the formula of the test statistic, when you go to step number 3, you can now calculate the test statistic. Okay, then step number 5, now you can make a decision and you draw the conclusions based on step number 5. Step number 4 on this one, let's check. So the one where you formulate the hypothesis, let's check. HO, we're talking about the null hypothesis where most of we always use equal sign. That the population is equal to maybe a certain value, or population 1 is equal to population 2 when you're dealing with the two populations. So HO, it's null hypothesis. Then alternative hypothesis SHA. This is under step 1. It's when you formulate the null and when they say formulate the hypothesis, you have to formulate the null hypothesis and also the alternative hypothesis. Okay. And another thing that is under step number 5, if you reject the null hypothesis, this is when the p-value, you'll see when we do the questions, when the p-value is less than the alpha, then we say that we reject the null hypothesis. It means that the minute we reject the null hypothesis, we can find enough proof that the null hypothesis is not true the minute we reject. But if we do not reject, or we fail to reject the null hypothesis, it means that we cannot prove that HO is false, which is the null hypothesis false. Okay. Then this one you specify. Remember, you will be given the significance level. Maybe 5% as 0.05 or 10% as 0.1. Then 1% as 0.01. Okay, then this is how you calculate the test statistic. Let's check the formulas. So for EG, we use this one when we are dealing with the large samples. We use this one when we are dealing with the small samples. This one here, the large sample and the small samples. I think there is a. Then now step 4, you compare the p-value with the level of significance. So that we say that if the p-value is less or equal to alpha, you reject the null hypothesis. But if the p-value is greater than the alpha, we do not reject the null hypothesis. Yeah, so that's how you do it. Step 5, then you make a decision. You say, okay, if I reject the null hypothesis, now I can draw the conclusions regarding the original research question. But if I do not reject, I also draw conclusions regarding the original research question. Let's start. Now, this is the hypothesis for one population. You saw the steps, 5 steps. So don't forget those steps. They're very important. Very important. Now, let's start with this one. Now, under the hypothesis testing for one population, when you formulate the null hypothesis, you always use equal sign. You see this part? Equal sign. Equal sign. You always use this equal sign, also equal sign. This one equal sign. But then now when under the alternative, you need to check on the question as whether they mentioned less than, more than, or they mentioned something like insufficient, or if they don't mention greater than, more than, exceed, or less than or shorter than, you're going to use this as the two-sided. We call it two, some they call two-sided, some they call two-tailed test. So you're going to do it. Okay, now this is very important. Step 1, you formulate the hypothesis. You look at the scenario, you make sure that you understand the scenario. You make sure that you understand the scenario. It's very important to check as well the value of n. Is it greater or equal to 30? If the sample size is equal to maybe 35 or 40, you're going to use the method of the Z. Because I think you did this on when you guys were doing STTN124 last semester. But it was under the central limit theorem, this formula. I'm not sure it's not the first time when you guys did this formula. Even those who are doing STTN121, then STTF122, they're doing this. So if the n is large, it's greater or equal to 30, you're going to say Z is equal to, you'll be given X bar, and then the population mean, and the standard deviation over square root of n. You get this, the test statistic. Remember, there's no need for you to calculate the p-value because you will be given the p-value. So there's no need for you to calculate the p-value. Then if n is small, you get the random sample which is small. So what you're going to do, if n is small, maybe n is equal to 20, but it has to be less than 30. It means you're going to use the t here. So it's very important to check if the n is it greater than or smaller than. Same applies to the hypothesis testing under the two population. So if the n is small like this, you're going to use the t. You can see that the formulas they are the same. You see x bar minus this one, and this one. The difference is that the other one you use it when n is greater or equal to 30. The other one you use it when n is less than 30. Yeah, and then this is where you're gonna get the degrees of freedom, which is Tn minus 1. So let's look at the question. Let's look at this. This is an example. Just do this. This is an example. So now this is the method that you guys can use to answer the question that are based on the hypothesis testing. I mean, chapter 3 is very easy and interesting. So this is what you do. So now look at this, the question. A manufacturer of a new cell phone battery claims that the mean lifetime. So it means that this is the population mean. So we can now see that the population mean is equal to 30 here. Okay, now check. However, an employee claims that the mean is less than 30. So now this thing of less than, it tells you that under the alternative hypothesis, HA, you're going to say HA where population mean is less than 30 because they mentioned less than, remember, and under the step 1 when you formulate the hypothesis. Now they say now a random sample, which is n, is equal to 81. So can you see now that n is greater or equal to 30? So what do we do if n is greater or equal to 30? You're going to use the method of the z. That method, the method of the z. Now they say that Bedris renders a sample mean. Remember the sample. What is the sample mean? They're talking about the x bar. So this is x bar is equal to 28.7. With the sample standard deviation of what? When you check here, the sample standard deviation of 8. So now we can see that already we are given everything here. We are given everything. So it's going to be easy for us to calculate what? To calculate the test statistic and also to formulate. Can you see that? So when you check here, they say test the hypothesis at 5% level of significance, which is the alpha. The alpha is equal to 0.05. The p-value, remember I told you that you will be given the p-value, 0.07. So before I even like write that down the steps, step 1, step 2, step 3, already I know the conclusion on step number 5. Why? Because I know step number 4 and step number 5. Because step number 4 is when you compare the p-value with the alpha, with the level of significance. So if it's 0.0717, it means that in this case, the p-value is greater than alpha. So therefore, what do we do? We do not reject. Because we said that the p-value, if the p-value is less than the alpha, we do not reject or we fail to reject the null hypothesis at 5% level of significance. So now here in this case, if you look at this, step number 1, you're going to have something like HO and the null hypothesis where the population mean is equal to 30. Then HA, the population mean is less than 30 because remember they mentioned less than 30. So this is, you see the method they used is equal to 30. Remember I said the null hypothesis you used equal sign. HA you're going to use less than 30 because on the question they said less than 30. So now what you're going to do, we're given the level of significance at 0.05. Now you write down the correct formula of the test statistic. We use the z because the n is large. It's greater or equal to 30. That is, which I think you got, it was 81. Once you write the formula, when you go to step number 3, you substitute your values. Because you see, x bar is 28.7 minus the population mean here, which is, it was 30. The population mean was 30. Already you're given the sample standard deviation. And then you do that, then you get the code negative 1.463. Now, when you go to step number 4, it's when you're going to compare the p-value. So it was 0.0717, which is greater than 0.05. Therefore, this one already you know how to do this one. Step number 5. Remember, if the p-value is greater than the level of significance or the alpha, we do not reject or we fail to reject the null hypothesis. Therefore, the minute we do not reject or we fail to reject the HO, we cannot prove that the average battery lifetime is less than 30 hours. Then you get, if it's 6 marks, 7 marks, or 8, you get 6 marks. So yeah. Okay, let's do the one when we are dealing with the small sample. Okay, let's check. Always make sure that you always like when you're given a statement or the scenario like this, highlight the keywords or the important values here. You see, a rugby enthusiast claims that on average, 5 tries are usually scored in a match. This will be our population mean here. Okay. A random sample of 25. So meaning our sample size here in this case is 25, which is now check n is less than 30. Therefore, we're going to use the method of the T. Okay, showed that the mean number of tries per match, it was 6.2. Okay, this one will be the sample mean with a standard deviation of 3.2. Now, does the mean contain sufficient information to contradict the rugby enthusiast statement? Assume that alpha is equal to 0.1 and the p-value is equal to 0. Okay, let me just do this. Okay. Is equal to 0.0073. So by just looking at the p-value and the alpha, I can make the conclusion. Okay, now the p-value 0.073 and 0.1. The bigger one is 0.1. Therefore, p-value is less than alpha. So what you do, you reject the hypothesis. But now check under those steps: step 1, step 2, step 3, step 4, step 5. Now check the value of n. Is it greater or equal to 30? No, here in this case, the value of n is less than 30, so we're going to use t. But now, when you check under the part of the alternative hypothesis to check if they mention greater than, more than, exceed, something like that. But when you check even the less than, the shorter than, they didn't mention any of that. So they just mentioned that does the sample contain sufficient information, which now it means that you're going to use two-sided or the two-tailed test. So what you're going to do, you're going to say HA population mean is not equal to 5. Let's check. Let's see. You see, here it is. Population mean under HO is equal to 5. But here is not equal to 5. Why? Here, because they do not mention something like greater than, more than, less than, shorter than, something like that. So we're going to take it as the two-sided here in this case. So this is the one. Now we're given alpha. We used the formula of T because when the n it was, we are dealing with the small sample, the n was less than 30, we used T. Then you do it like this, then you substitute your values. You saw there it was 6.2 minus 5 divided by 3.2 over and then square root of 25. This is the method they used. They got 1,2875. Now here we're going to compare 0,073 with the 0,1. So it means that the bigger one will be 0,1. So therefore 0,073 is less than 0,1. Therefore therefore we reject the null hypothesis. This is step number 4. When you go to step number 5, you'll say you reject the null hypothesis. The minute we reject the null hypothesis, we can now conclude that we have enough proof, enough evidence to contradict the enthusiast statement. And you get the marks. Okay, this is an exercise. Let's see. Okay, a statistics lecturer claims that the students in his class study an average of 80 hours. So this one will be what? The 8 hours will be the population mean. This one will be the population mean, okay, for the exam. He draws a sample of 60. So can you see now n is greater or equal to 30? N is greater or equal to 30. So therefore, what are you going to do? You're going to Z because n is greater or equal to, you're dealing with the large sample, and ask each of them how many hours they studied for the exam. The average of the sample, this will be the sample mean, take an X bar with this one. This will be the X bar here, the X bar here. And then the variance is 16. Since you're given the variance, you need to convert this to a standard deviation. You know that when you are dealing with the standard deviation, for you to get the standard deviation, you need to do a square root of that variance, which will be the square root of 16. To get the standard deviation, you will get 4. So I mean the standard deviation will be equal to 4. That will be the standard deviation. So now they said use what? Use the level, a significance level of 10%, use 0,1 to test the lecturer's hypothesis. So already you're given the alpha. Now to get this, you see when they say what are the null and alternative hypotheses, you get something like this. Something like this. You will say Just do this. You will say HO, where HO, okay, where population mean is equal to, the answer that we're given is equal to 80, and then HA is equal to, HA where population mean is equal to what? It's not equal to, because it's not equal to 80. I'm going to put the symbol. This is the symbol that I'm going to put. The symbol of not equal to, which is the two-sided. This is the symbol that I'm going to put here, because they don't mention as whether it's greater than, it's more than, you see, something like that. So now, to get the test statistic, you know the formula that you're going to use, the formula that you are going to use. Z, so that the formula of the large sample, X bar, and then minus the population mean, and then divide by the standard deviation over square root of n. Already X bar, it's 78.7 minus 80, divide by the standard deviation is 4 into square root of 60. Then you get the test statistic. Then you got this one. So now you're given the p-value as 0.0118, and also you're given the level of significance. So between 0.0118 and 0.1, we can see that the bigger one is the level of significance. Therefore, we reject the null hypothesis at level of significance. Then you can now draw a conclusion. If you reject, you saw that most of them, when we reject, we can now conclude that there is enough proof or enough evidence. So that's how you do it. So yeah, what's the other one? I think it was 3.2. Let's check 3.2. The hypothesis testing for independent, but let me check this one also, because we have 3.2. Okay, we did one population, and now, okay, I think I'm just gonna put this one here. We did one population, and now we're on two population. You saw the method of one population, the hypothesis testing, even the steps, you saw them. So now this one, the two population, we have the independent population, we also have dependent populations. So let's see. Let's see. So the independent populations, it's when the two populations are said to be independent of each other. Okay, let's see. The one for the dependent. Okay, this is very important. Now, I believe now you saw the method. You saw the method for one population, the method that we are going to use. Either you can use the one for the large sample or the small sample. Under the two populations, we have independent, we have dependent. When you check, you need to check if N1 and N2 are large. Check N1 and N2 are large. Check also if N1 or N2 are small. Check also under the dependent if N1 and N2 are large, and check if under N1 or N2 are small. The question is, if you're given a scenario or you're given a table, how will you see that this one is based on? But I believe that you saw that the one for the one population, I believe you saw how to get the test statistics and so on, the hypothesis testing for one population, the question that you will be asked. But then with this one, the independent dependent, I'm going to show you guys the method on how to see that this one is based on the independent, the other one is based on the dependent. Let's go. Let's see. The steps still the same thing. You already, no need for me to explain the steps again. You saw them. Step 1, step 2, step 3, step 4, step 5. Okay, let's see. We start with the one for the independent. When N1 and N2 are large, the one when N1 or N2 are small. The formulas are not the same. Let's see. Under the independent. Also, with regards to, since we're dealing with the two populations, you saw that when we were dealing with the one population, we used to say that when we formulate, we used to say that population maybe is equal to, maybe if it was population mean was 20, we used to say it's equal to 20. You saw that name. But now this was one population. With the two population, it's when you compare the two population means. So under the null hypothesis, we always use equal sign. Population mean 1 is equal to population mean 2. Always. 1 is equal to population mean 2. Always. This one. It's this thing is the same as 1 is equal to 2. 1 is equal to 2. But when it comes to the part where under the alternative, or again, look, check at read the statement, check if they mentioned is population mean 1 less than or shorter than population mean 2, or population mean 1 greater than population mean 2. Check that. If they didn't mention greater than, more than, or less than, you're going to take it as the two-sided like this. It's going to be something like this. It's going to be population 1 is not equal to population mean 2. This one. That's how you do it. And if it's greater than, you're going to choose this one. If it's less than, you're going to choose this one. Also, step number 1, check the value of n. Is n greater or equal to 30? N1 or N2 large? Same applies to one population under hypothesis testing. You saw that when we are given a scenario, we check the value of n, we checked the statement under the alternative. If it's greater than, less than, or more than, so that you don't lose marks. Okay, let's see. These are the formulas that you are going to use. 1. If n1 and n2 are greater than greater or equal to 30, we're still using z. Just that now we're dealing with the two populations. That's the reason why it's x bar 1 minus x bar. You will be given those x bar 1, the variance of the standard deviation 1, n1 and n2. The only thing that you need to do, check n1 and n2. Are n1 and n2 large? If they're large, use the z. Then under the one for the small, check n1 or n2. Are n1 or n2 small? Use the t. But be careful of this. When you use the t, when you look at this formula, you'll be given this, you'll be given this, but you won't be given SP. For you to get the SP, remember, you need to use this formula. Obviously, you will be given maybe the standard deviation 1 under the population 1 and the standard deviation 2 under the population 2. You'll be given N1 and N2. Once you get S squared P, once you get this, S squared P, for you to get, you see on this thing, it's SP, not S squared P. For you to get SP, you're going to do a square root of that S squared P. It's like when when you're given the variance and you need to find the standard deviation. Now you do a square root of what? Of the S squared P, something like this. So that when you substitute this here, you will get SP. You see, the value that you're going to get for S squared P, you're going to do a square root of that value, then you get SP. That's how you do it. Check N1 and N2. Okay, let's see. This is, okay, we were given the hint, but let's check here. Don't forget those steps. Let's check. A study is done to estimate the difference in salaries of teachers in private, and also have the one for government schools in a specific education community. Now, a random sample of 100 teachers at private schools. So it means that we have the population of the teachers at private school and a population of the teachers at government school, which we can call the one for the private school at population 1, and then one for the government school at population 2. So the 100, this one will be N1. This one will be N1. Okay, showed an annual mean, which they're talking about X bar 1 of 105,000, which this one will be X bar 1 because it's under the population 1, X bar 1 here, X bar 1, and then now we're also given a standard deviation 15,200. So this one will be S1 here. Okay, now we are done with the population 1, the one for the private schools. Now this is a random sample of 200 teachers at government schools. Okay, but let me just do it like this. Choose this one. 200 teachers at government school. Now this is the population 2. Realize that, so the 200 will be N2. Can you see that? N2. So that's how you do it. Before you even do the hypothesis testing, you do the steps. Try to find the important things here, the keywords. So now realized a mean annual salary of 88,000, which will be X bar 2. X bar 2. This one will be X bar 2, like this. Okay, with a standard deviation of 13,500. That's the deviation of 13,500. Okay, which will be, where is it? Which will be standard deviation number 2. Number 2. Now test that the mean salary of teachers at private school is higher than. You see now the statement higher than. This statement under step number 1, it tells you that the population of the private school will be greater than the population of the teachers at government school. Meaning the population 1 will be greater than population 2. You see, already you know the answer for step number 1 and the alternative. Okay, we're given the significance level of 0.05, the p-value 0.0001. So, but we can see that 0.05 and 0.001, the bigger one is 0.05. Therefore, the p-value is less than alpha. We reject the null hypothesis at 5% level of significance. Sweet. Okay, let's check. Let's check. Here it is. Now you see the reason why I said it was greater than. This one you always use equal sign. Get it here? The greater than comes from this part here, where they mentioned more than, higher than here. That's the reason why they used this. You get that one, step number 1. Step number 2, rather than the formula. Remember, when you look at N1 and N2, N1 is 100, N2 is 200. So they are above 30. And we say that if N1 and N2, they're greater or equal to 30, we use the large sample, which is the Z formula. This is the formula that they used. This is the formula under step number 2. You specify the level of significance, which is, it was 0.05. You write down the formula for the test statistic, which is this the formula that you are going to write. Step number 3, you substitute your values. So the values you saw them, I was busy highlighting those values, x bar 1, and then you just like that. Then you get the test statistic. Step number 4, you are going to compare now the p-value with the level of significance. P-value is 0.0001 and alpha is 0.05. Therefore, p-value is less than alpha. Step number 4. Step number 5, since the p-value is less than alpha, what we do, we reject the null hypothesis at 5% level of significance, which is this one. Therefore, the minute we reject, it means that we have enough proof of the evidence that the mean salary of teachers at private school is higher than those at government school. Then if it's 6, 7 marks, you got free 6 marks or 7. So yeah, this is the one. Now let's look at the one for the small sample. And how do you see that it's small sample? For 2, already we're given everything here. For 2 random sample sizes, N1, it's 11, N2, it's 14. So already you can see N1 and N2, they're less than, both of them, they're less than 30. So therefore, we're going to use the method of T. Where on that T, we're going to use the one for the SP and the SP squared. I think I explained it there. Now, already this one, we're given the X bar 1, the sample mean 168, sample mean 260, standard deviation 178, standard deviation 2, 8.4. Okay, now a test should be conducted to see if the population is identical. Already we're given everything here, also given here. So it's going to be easy for us to do this. So alpha is 0.01, the p-value is 0.23. Already you can see the p-value is greater than alpha. So therefore we don't reject, or we fail to reject the null hypothesis at 1% level of significance. So let's see. So step number 1, that's how they do it. It is, they use the two-sided, because remember, we're given this. Okay, step number 2, we just specify the level of significance. We write down the correct formula. We use the T. Now, this is very important, the SP. But you need to get the S squared P. After you do a square root of that, you S squared P to get SP. Let's see. You see what they did here. The value of the S squared P, they got 66.341. To get the SP, you do a square root of 66.341. Then you get this. That's the value that you're going to substitute there on your test statistic formula. You substitute your values, you get the test statistic as 2.438. Okay. Then now we are going to compare the p-value with the level of significance. So since it's 0.23 and the alpha is 0.01, it means that now the p-value is less than alpha. Therefore, what you do, step number 5, you do not reject the HO at 1% level of significance. Therefore, the two population means they do not differ. Because we failed to reject the HO, then we are done. Yeah, these are the steps. And then now, I think now we did the one for the independent. You saw how they do the questions that are based on the independent, how they got N1 and N2. How do you see that this one and this one? You will be given a statement there. Then you just check N1, you check the large sample, the small samples, you check if it's greater than or less than. That's how you do it. So now we're going to do the one for the dependent. Now you know the hypothesis for one population. You know the hypothesis for two population under independent. on how do you see that N1 and N2 are large, which formula you're going to use? The N1 or N2, which are small. Let's look at the one for the dependent. When when N1 and N2 are large, the dependent, and when N1 or N2 are small. Let's see. Okay, you know the formula. You saw this one, we did it. You saw even this one. It was under the independent. Interesting one. The one for the dependent. The one for the dependent, when N1 and N2 are large, we use this formula. I'm going to explain it there on the next slides on what is this D to the power, this D, what is this SD, what is this TD, and what is this SD. How do you deal with this whole thing under the dependent? Now you saw how to deal with the independent and the hypothesis testing for one population. You saw that. Né? Let's do the one for the dependent. I think this is 3.2. I'm going to find it there under wait, 3.2 again. This is the one. Let's see. The steps are still the same thing, remember. It's the same thing. This is how you do it. Now, here, you need to be careful of this name. Under the null hypothesis with this one, you are just going to say HOUD is equal to 0. Now, it's very important for you to check this as whether it's less than, greater than, or two-sided. Okay? What is this UD? That is the population mean difference. This type of questions, it's when you will be given a table. You will be given a table. On that table, you are going to find a difference. Once you find the difference, you remember when you guys were doing STTN124 last semester, you were given a data set. There was a method that you guys needed to use to find the standard deviation and a mean on a calculator. Same thing applies to this one. Once you get the difference values, you're going to punch them on a calculator to get the mean and the standard deviation. That mean and that standard deviation, you call it the mean difference and the standard deviation difference. That's the reason why it's D to the power D bar and also SD stand for the standard deviation of the difference. Okay, let's see. Let's go and check the question. Here it is. Now check the value of N. If N is large, you're going to use the one for the C. If N is small, you're going to choose the one for the T. But you see, the D, SD, N is the same thing here. But you need to check if N is large or small. But most of the time, with this kind of question under the dependent, the population under the dependent hypothesis testing, the sample will be small. You will be given you will see on the table when we do the questions. Okay, this is what I'm talking about. Look at this. Look at this. Okay, they say this is a table that I'm talking about. You will be given a table. Let me show you something. I was on this one on 3.2 under this one. Okay, I just want to show you something on maybe 2019. When I say that you will be given a table on how do you see, now you know the hypothesis testing for one population, you know the hypothesis testing for independent, and then now the dependent one, the one for the mean difference, the standard deviation difference. Let me show you something. And how do you see the table that I'm talking about? If you will be given the table. On this one, it was not there. Let's see this one, this question paper. I just want to show you something. You see, when you look at this, okay, let's see. Just want to check something. The table. No, on this one, you also not given. Let's check 2023. 2023 should be given the table. Is it the one that I want? If you will be given a table. Is it? You can see even on this one, you were not given a table, but when you check this one here, you will be given a table like this. If it happens that you're given a table like this, you see here the blood pressure of 4 people before and after treatment. This is before, this is after. Calculate the test statistic. You're still going to use the same steps. So we're given the blood pressure of before and the blood pressure of after. So what you're going to do, remember, this is the dependent samples. Right? You need to get what you call the difference. Once you get the data of the difference, you're going to punch it on the calculator. You get the mean, you get the standard deviation. In this case, what you're going to do, so it's going to be 138 minus 138, 145 minus 124, 21, 130 minus 120, 11, 128 minus 119, 9. Once you get this, you're going to punch this on the calculator using the method when you guys were doing the STTN triple one last semester. You get the mean. That means that you're going to get there on that method that you remember last semester method. That will be the mean difference. Then the SD will be the standard deviation difference. Okay, so that's how they did it. You see, they used that method. Okay, and then the sample, because they said 4, 1, 2, 3, 4. The n will be 4. Because this is less than 30, you're going to use t. So this is the method. Then this is the method that they used. Use the t. Use the t, then you get the test statistic. Okay, let's check. So now you know how they used these two formulas. You see, this one and this one. You saw it. Okay, it was 3.3. Let's check 3.3. I think it was this one here. Yeah, it's the same thing that we're talking about. So now we talked about this formula. You know how these formulas work. Even this one, the two population and the independent, and even also this one, the main difference, and also that one. You see now, you'll be given something like this. You see, you're given the table. Ne? You have before and after. For you to get this and this one, you need to get the difference. 23 minus 76. This one minus this one. This one minus this one. Till 20 minus 15, you get 5. You're going to punch these values. The values that you're going to punch in the calculator to get the mean here, there. Even the negative one, you have to punch it there, even one. Then you go use the step, you say the AC shift mode, shift option 1, you go to the option of var. Then after that option of var, you go to the mean, and after you go to the standard deviation, you write them down. So now you're also given the alpha is 0.01. You're also given a p-value of 0.00451. So therefore, we can say that the p-value is less than alpha. Therefore, we reject the null hypothesis at 1% level of significance. Let's see the steps. You see, but when you look at this, let's look at the question. The time in minutes it takes operators to fit a certain part before and after completing a training program is tabled. Determine if the mean fitting time decreased. So we're going to use less than. Remember, you just say UD is equal to 0 because of the decreased, which you are going to use less than. Now, step number 2, you specify the level of significance we're given alpha. Because now, look at this. 1, 2, 3, 4, 5, 6, 7, 8. N is equal to 8. It's less than. It's small sample because it's less than 30. So therefore, we're going to use T. Use the T here. Then you substitute. You get the test statistic 3.577. Step number 4. They're trying to show the method on the calculator, but use the one that you guys know from the STTN124 to get the mean and the standard deviation. So step number 4, you compare the p-value with the level of significance. Therefore, the p-value is less than this. We reject the null hypothesis on step number 5. Therefore, now you're gonna say, since we reject the null hypothesis at 1% level of significance, the training program did decrease the mean fitting time. Then you're done. It will be step number 5. That's how they did that thing, that exercise. Even this one, you see, before and also after, you do the same thing. This one minus this one, you get the difference. This one minus this one, and you need to check if they mention greater than or less than. Yeah, so that's how you do it. So then yeah, that's how you do it. And then what's the other part? I think this one. I think we talked about this. Even this one. See the formulas, we talked about them. You know these formulas, talked about them. This, you see, questions. You see now, you check. You're given this. Remember, check N1, 37, it's greater than 30. 35, greater than 30. You know that you're going to use Z. If you're given a table, you're going to use the one for the D, SD, and so on. But this one, it's for the independent. So you're given alpha, you're also given the probability. So you're going to use the method of the Z. But check if they're talking about greater than, less than, or shorter than. So here, they said shorter than. So it means that population 1 is less than population 2. You see here it is because of the shorter than. So then you just follow the steps, you do it like that. I think we did the questions under this independent, then you get the answers. So yeah. But if it happens that you read the question and you see that on that question you are given maybe you one population mean, one population standard deviation, and the value of n1, that thing it's the hypothesis in under one population. But if it's 222, it's two population under independent. But if it's the table, it's the one for the difference, the mean difference, the standard deviation difference. But the steps are still the same thing. You see here, like this. This one is also two. It's also two population because what you're going to do, you're going to find the mean for this one. You're also going to find the mean for this one, the mean for one and mean for the two. You find n1, you find n2. You find the standard deviation one, you find the standard deviation two. Using that method from STTN124 to find the mean. So this is the method they used because obviously when you're given that table, n is less than. If you're given a table of before and after, use the difference, the one for the difference. See, that's how you do it. And now with this one, talked about this. Let's see. That's an exercise question, so you can try to do these questions. Yeah, I think that's the one. Yeah, you saw it. Let's check 2024. That's this question paper. Let's check this one. But also out of 25. Oh, okay. Let's see. Yeah. Unfortunately, this one is a question paper plus a memo. Let's check. So a meteorologist claims that the average wind speed in winter at a certain location in the Sahara Desert is 8.98. That will be the population mean here per second. However, a sample of the wind speed observed on 31. This is greater than 30. We are going to use the Z to work with the test statistic. Winter at the same location yields a sample mean of 9.17, a standard deviation of 1.135. Already you can see that for this one, to formulate this, did they mention something like greater than or less than? No. But let's check. However, observed is chosen. Oh, wait. Okay, wind speed. However, a sample of the speed chosen in days winter at the same location yields a sample mean of and a standard deviation of times the average winds at in the east and the meter span. So when you formulate this, you see that state the null and alternative hypothesis to test whether there is evidence in the data to prove that the average wind speed exceeds, which is greater than. So it means under an alternative, you're going to say greater than. That's the reason why they did this. You see, greater than. Then null hypothesis, this is the one. Then they give you 1 mark. Test statistic, remember I said you're going to use this formula, the Z, because n is greater than greater or equal to 30. That is 31. There. Yeah, that is 31. Then you just substitute the values here, and then you get the test statistic and you get 2 marks. And now it is found that the p-value is 0.00142. Or we are going to compare the 0.00142 with the 0.01, the significance level. So therefore, we're going to reject. You check the hypothesis. So the minute you reject, now we can now say that yes, there is enough evidence, or you can now prove that there is enough evidence to say that the average wind speed exceeds 8.98 because we rejected the null hypothesis. Then you get 2 marks free. What's the other one? Is it? Okay, suppose it is found that there is a statistically significant difference. They're talking about the method of the difference between the sample mean and the population mean. Calculate and interpret the value of the suitable effect size to test whether they is statistically significant. So what you're going to do here to get the difference on this one, to get what we call the effect size of the difference, it's simple. The x bar minus the mean divided by the standard deviation, and then you get this. Then you're done. Then you check. If it's 0.167, it means that it indicates that it's a small effect. I mean, the difference is not practically significant on that one. We're given the northern hemisphere and the south there. When will we get this? Yeah, the information. A study is performed to determine whether stargazers, okay, on average see an equal number of shooting stars in there. Okay, the information. Furthermore, the standard deviation of 2 samples, you see, sample one, standard deviation of this, and standard deviation of this. By just looking at this, you can see that the method we're going to use is the one for the two population. And check the n. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Large. It will not small. We are going to use the method of the t. But check if they mention that this one is greater than this one or this one is less than this one. But when I look at this information here, there's no part where they say this one is greater than this one is less than. So we're going to use two-tailed. You see, population 1 is equal to population 2. Population 1 is not equal to, because they didn't mention greater than, less than, and so on. The test statistic, this is the formula, the t, because and we're dealing with a small sample. You substitute your values there. But now, because you are given this, you're going to find the mean for this one in the calculator. You're going to also go to find the mean for this one in the calculator. The n already, you can just count the number of observations here. You get n1. You also count here, you get n2. So on their side, n1, it's what they calculate the mean, but you can also use a calculator to get this mean. You can also use a calculator to get the standard deviation. Remember the SP. Once you get this S squared P, you need to do a square root to get SP. Then you substitute your values there. Then you get the test statistic. Then now, they also want the same thing. Once now, they also want to what? Calculate and interpret the value of the suitable effect size. D x bar 1 minus x bar 2 divided by S squared SP. You got the SP there. You saw it. So x bar 1, we got the sample mean 17.45 minus sample mean 26 divided by the SP. Therefore, it was 0.997. You remember on the previous one, it was 0.167? That was small effect. This one, it's large effect because you see the difference means it shows that it's practical significant. Then you get 3 marks. Then what's the other one? This one is ANOVA. And I think I'll have to explain that one. I think on a later stage, yeah. So you can also try the other question papers. You will see that this is interesting. Yeah, please don't forget to like and subscribe to my YouTube channel so that you can see more videos of STTN124. Thank you.